In this question, we are required to calculate the rate constant of a first order reaction from some given data. So we know for first order reaction we can use the equation Ln is the concentration of an A final concentration over A initial concentration equals negative K times T final minus T initial. And what we really need to do is figure out what we use as final and initial. So we can use any pair of data here, it doesn't matter. Let's say we go for A final, that is the last one that we have, that is 223 millimolar, and the T final, that is 150 minutes. That's the corresponding value. And for the A initial, let's go for the first one that we have. We have 639 millimolar, and the T initial equals 10 minutes. And what we can do now is we can just simply rearrange our equation. We bring the TF or minus T initial to the other side. Then we have minus K equals Ln A final over A initial divided by T final minus T initial. So if we put data in, what we just said, Ln, we have 223 divided by 639 divided by 150 minus 10. And here we need to contain the minutes. And for that, if we do this calculation, we get here we get Ln 0.33 divided by 140 minutes. And this gives us, if we bring the K to that side, this gives us a rate constant of 7.51 times 10 to the minus 3 minute to the minus 1. Now that is the result that I needed to see. It's very important that we have the unit here, because a number without a unit is just simply nothing. So I realized that a number of people put in, for one reason or the other, second to the minus 1. I don't know where the second to the minus 1 comes from. It definitely is not correct, but I've accepted it as long as it was a time to the minus 1. But in future, for those of you who did that, please make sure that you use the correct unit. Now we also want to calculate the final concentration at a time of 200, so that's this part here. And to do that, we've just calculated our rate constant. We use the equation. Where's it gone? There's it gone. We use the equation A final equals A initial times e to the power of minus k times T final minus T initial. So our A final, that is what we are looking for. And the T final, that is 200 minutes. A initial, we can take our starting concentration, that was 639 millimolar, the starting time, that was 10 minutes, and our K equals 7.51 times 10 to the minus 3 minute to the minus 1. So we have everything that we need to put into our equation. So we have A final equals 639 millimolar times e to the power of minus 7.51 times 10 to the minus 3 minute, 200 minus 10 minute, and this gives us, eventually when we do everything correct, then we come up with 153.1 millimolar. Now a quick check for our data table. We see that here that the value for 200 minutes with 153 is clearly below the 223 millimolar that we had for 150 millimolar. So that is indeed a value that does make sense. So I wanted to see really this 153 millimolar, and important is that it has again a concentration attached.